In places like California or Japan, the ground is rarely silent. Small tremors and rattling dishes are a common part of life. But in the Pacific Northwest, the coastline is still. The ground feels permanent, and the history books are quiet. This silence is an illusion. Just off the coast lies the Cascadia Subduction Zone, a 700-mile-long fault line stretching from northern California all the way up to Vancouver Island in Canada. Two massive slabs of the Earth's crust are colliding here. The oceanic Juan de Fuca plate is slowly sliding beneath the North American continental plate. However, the two plates are currently wedged tightly together. They are stuck, and the North American plate is bulging upward as centuries of geological pressure build beneath it. For decades, 20th-century geologists lived with a terrifying paradox. The Pacific Northwest had the exact geological anatomy to produce massive earthquakes, yet there was no written history of one ever happening. This left scientists to decide if the Cascadia Fault was harmless, or a bomb that simply hadn't gone off yet. In the late 1980s, geologist Brian Atwater was exploring the tidal marshes of coastal Washington when he found groves of dead, sun-bleached cedar trees. These eerie groves are known as ghost forests. Western red cedars cannot survive in saltwater. For a long time, it was assumed the sea level had risen over the decades, slowly drowning the roots. But the soil layers showed that the trees died because the solid ground beneath them had suddenly plunged several feet into the ocean. These drowned trees provided the physical proof of a massive land subsidence event. It kicked off an international search to find out exactly when and why the ground collapsed. To find the exact date the ground collapsed, scientist David Yamaguchi analyzed the tree rings of the dead cedars. The results were remarkably precise. Because trees do not grow during the winter, Yamaguchi was able to see that cellular growth up and down the coast stopped simultaneously between the late summer of 1699 and the spring of 1700. This matched a completely different set of records, the oral histories of Native American tribes across the coast. These stories often described an epic battle between a thunderbird and a whale. They detailed violent ground shaking followed by a massive rush of salt water that flooded the land. Tribal genealogies and stories of surviving canoes hanging in trees placed this catastrophic flood roughly 7 generations in the past. When researchers tracked those generations back, they arrived at the year 1700. The tree rings and oral traditions proved a massive localized catastrophe occurred in 1700. But scientists still needed precise data to understand the true global magnitude of the event. 5,000 miles west, Japan held the final piece of the puzzle. Because the Japanese coast is so vulnerable to tsunamis, samurai and merchants have kept meticulous records of flooding for over 1,000 years. In January 1700, their records describe a massive wave that struck the coast and destroyed homes, but no one in Japan felt an earthquake before the water arrived. They called it an orphan tsunami, a wave with no apparent parent. In 1996, seismologist Kenji Satake finally matched that Japanese orphan tsunami to the ghost forests in North America. By combining the Japanese wave heights with computer models of the Cascadia Fault, researchers pinpointed the exact moment the earthquake began, January 26, 1700, at approximately 9 p.m. The calculation was terrifying. To generate a wave large enough to cross the entire Pacific Ocean and destroy Japanese villages, the earthquake in the Pacific Northwest had to be a magnitude 9.0. This discovery proved that 1700 was not an isolated event. Paleoseismologists began taking deep-sea core samples off the Cascadia coast to read the history of past underwater landslides triggered by massive shaking. The seafloor tells a story of repetition. The Cascadia Fault has violently ruptured 41 times in the last 10,000 years. This reveals a mathematical pattern. Dividing that 10,000-year history by the 41 events shows an average recurrence interval of roughly 243 years. Counting from 1700, we are over 300 years into the current cycle. The fault is significantly overdue. The 1700 earthquake proves that the Cascadia Fault is a cyclical machine, currently loaded with over 3 centuries of pent-up tectonic pressure. When that pent-up pressure finally overcomes the friction between the plates, the continent will violently rebound like a spring. The locked coastline will drop up to 6 feet, and the North American plate will snap forward up to 100 feet to the west. Up to 5 minutes of violent shaking will follow. The ground will undergo liquefaction, triggering widespread failure of infrastructure across the entire region. Within 15 minutes, a massive tsunami wave up to 100 feet high will reach the shore. It will be a deluge of debris, moving with enough force to scour the inundation zone of all structures. The region's primary risk lies in its vulnerable infrastructure. Because the threat was discovered so recently, the vast majority of buildings, bridges, and schools were constructed before modern seismic codes were written. Understanding the 1700 Orphan tsunami is our only warning. We are living on borrowed time, and we must use it to prepare for the inevitable arrival of the next big one.